Hey guys, what's up? My name is Gabe and this is Games with Gabe. If you recall in the last tutorial, we went over something called while loops where say you want to go through a range of numbers or something, you can or repeat an action until a specified condition is said to be false. You can say something like I equals 0 while I is less than 10, print I, and then we will say I equals I plus 1. And if we run this, we should get a number counting from 0 to 10. So if we say python temporary.py, it prints them 0 to 9, which is what we would expect since we said less than. And then if we change this less than or equal to and change that to 1, run this one more time, it goes from 1 to 10. Okay, so this is how you can repeat an action for a specified amount of times, but it's a little bit cumbersome and there's quite a bit to write. Python provides a shorthand, which we will learn about in this, and this is called a for loop. So if you write for I in range 1 to 10, print I, it's going to do the exact same thing as this while loop. So we'll take this out for a second, and then I'll say python temp.py, and it does the exact same thing. It stops at 10 though. So basically what this is translating it into is this loop right here, while I is less than 10, print I, and then I equals I plus 1. So you can basically do the exact same thing. You can change this up a little bit, and this is basically just a shorthand to make it a little bit easier to write these things, because you tend to have to write something called a loop, for loop, especially going through a range of numbers quite often in programming. And so there's a couple different things you can do if you want to customize the loop a little bit. Say you want to count up by 5s. You could say for I in range 0 to 100, and then if you add in a third comma and a third parameter, a third number, it will tell it what to increment it by. So going up by 5, and then we print I, then we run this, we should get going up from 5, 0, 5, 10, all the way up to 800. So temporary.py. And you notice it goes 0, 5, 10, 15, 20, 25. So just like that, up to 100. And so you can basically customize this any way you want. Say you want to go backwards, go down. So for I in range 10 to 1, going down by -1, print I. This should go 10, 9, 8, all the way down to 2, because 2 is right before 1. We'll print this out, and you notice it goes 10, 9, 8, all the way down to 2. So you can customize this to whatever you want, however you want it to work, and it will work exactly the same way. So this is very useful whenever you need to just compute over a range of products. The while loop is more useful when you want to keep doing something you don't quite know how many times you need to do it. So that's sort of the difference of when you would use this one versus the other one. Okay, so what's a little programming exercise that you can do to get used to this, to get used to the idea of loops? Well, there's something called the Fibonacci sequence, which you can try and program using a loop. So say the user enters some input, we'll say input, enter a number, and then we want to keep doing something until we hit that number. So if we want to turn this into an actual number, remember we have to say int and then wrap it in parentheses, and this will translate whatever the user enters into a number. Then we can say while, we'll set up a counter, say that's 0 while counter is less than user in, and then we'll say print do some stuff, and then we will say counter equals counter plus 1. So we run this and it should ask us for a number. I'll say 4. And then it's going to do whatever it wants 4 times in this loop. Okay, and so now on to the Fibonacci sequence. What is the Fibonacci sequence? Well, that's the sequence of numbers that looks like this. You have the first 2 numbers are 1, 1. Then the next number is the previous number plus the number before that. So 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 2 is 5. 5 plus 3 is 8. 8 plus 5 is 13, 13 plus 8 is 21, so on, so forth, forever. Now, how can we code a program where when the user enters a number, say the user enters 3, it returns 1, 2, 3, which is 2. Say they enter 5, it should return 1, 2, 3, 4, 5, which would be 5. We want to write a program that basically just returns whatever index they write and whatever number that would be. So how would we do this? I'm going to give you the first couple bits of information you're going to need. So we'll say f of n equals 1, or we'll just say 0. F of n minus 1 equals 1. Fn minus 2 equals 1. So we're basically just initializing these three variables and using these three variables, which represent, so 1, 1, this is f of n minus 1, this is f of n minus 2. And then we can actually initialize this to 2 so that it's all working out as it should. So I'll give you the first three numbers. Now using these three numbers and whatever the user enters, I want you to come up with a loop that calculates whatever index. So if they put 3, it should put in the next number in the sequence. 4, it should put in the next number after that, so on, so forth. Now pause this video, try that real quick. I'm assuming you just tried that, whether successfully or not successfully. Now what we're going to do is we're going to go over how I would do that. So say we want to come up with how this should work. We're going to have to do a couple things. So let's do the easiest thing first. We know that f of n is going to equal f of n minus 1 plus f of n minus 2. That part's easy. But then we need to move f of n minus 1 up by 1 and f of n minus 2 up by 1. How do we do that? Well, first we should say temporary equals f of n. So we want to store f of n in a temporary variable just so that we don't lose that real quick. Then what we can say is f of n minus 2 equals f of n minus 1. So we're moving that one up by 1, and then we'll say f of n minus 1 equals temporary. But we're going to want to actually do this after we increment f of n. So we'll do f of n equals that first, and then we will do these two, and then we'll increment the counter. So what's happening here? You can do something called a comment if you want to keep things straight. Put a hashtag in your code at the end of a line, and then whatever you write after that will be ignored by the programming language. So right here, let's go over the first iteration loop. Temporary equals f of n. So that means temporary equals 2. Then we're saying fn equals fn minus 1 plus fn minus 2. Well, then this means that fn equals fn minus 1, which is 1, plus fn minus 2, which is 1. So fn is actually going to equal 2. And then we're going to say fn minus 2 equals fn minus 1. So now fn minus 2 is going to be 1. Fn minus 1 is going to equal temporary, which is 2. So fn minus 1 is now going to be 2. And then counter equals counter plus 1. I've actually noticed an error in my code here. We should probably not be assigning fn to fn minus 1 plus fn minus 2, but we should be assigning it to fn plus fn minus 1. So that way we get fn, so temporary equals fn here, that's 2. And then here we would get fn equals 1 plus fn minus 1, or this would be 2 plus 1, which is 3. So fn equals 3. And then down here, fn minus 2 would equal fn minus 1, so that's 1. Fn minus 1 would equal temporary, which is 2. So this would equal 2 now. And then counter equals counter plus 1. So now on the next iteration, we would say temporary equals fn. Well, what's fn? Fn is 3. So temporary equals 3. What's fn? Fn is fn plus fn minus 1. Well, what's fn minus 1? It's 2. So then fn is fn plus fn minus 1, which is 3 plus, and then fn minus 1 is 2 now, and which is 5. So as you can see, this is going to continue going, and I've actually also noticed that we don't need this fn minus 2. So if that threw you off, I'm sorry about that, but you actually don't need that. So let's run this real quick and just see what happens and make sure it's working as it should. So Python temporary.py, enter a number, I'm going to say 2. Oh, and then we should actually print out the value afterwards too. So we'll say print fn. Okay, so we'll say Python temporary.py. We'll enter 2. and it gives us 5. So let's write out this sequence once again. 1, 1, 2, 3, 5, 8, 13, so on. Okay, and then we'll actually comment this out. We'll just have this here for reference that we can see if it's right. Now, it says 2 is 5, but if we look in here, 2 should actually be 1. Why is that? Well, we're actually starting it off at the 3rd index, so we should actually put counter equals 3, and then if they print, so then we'll say if the user in equals 1, this is just a little optimization. You don't necessarily have to do it this way. It'll work fine no matter what you do. We can say then the user input equals 1, then we know that they're asking about this one. We'll just say fn equals 1, else if the user input equals 2, then we'll just say that it also equals 1, fn equals 1, else if the user input equals 3, fn should equal 2. Okay, and then this should give us the correct value now no matter what. So let's rerun this. We'll say 2, and it gives us 1. We give 3, it should give us 2. We give 4, it should give us 3, which it does. If we give 5, it should give us 8, or nope, 5. And if we give 6, it should give us 8, 7, it should give us 13, and then 8, 21, 9, so on and so forth. And then you can enter in a crazy number like 100, and it gives us this insane number. I have no idea if that's right or not. I assume it's correct because it was working correctly with all the other ones. So hopefully you solved that. If you didn't, I'm sorry. It might have been a little bit misleading having this variable here, which we didn't actually need. So I will try and edit that out as I go through and re-edit this video and tell you that you don't actually need fn minus 2. Okay. So this about covers it for for loops and while loops. I hope you guys learned something. One more interesting loop problem that you might want to try is the square root. So I'm going to pull up the formula for that real quick. Okay, so I basically want you to try and code this algorithm with a while loop. So this is very similar to the Fibonacci sequence, except it calculates a square root. All it's saying is xn plus 1, basically where we were doing fn plus 1, equals 1/2, so just take this right portion right here, 1/2 times xn plus s over xn, where s is the number you're trying to take the square root of, and x0 is the number you're trying to take the square root of. So if it was 4, then x of 0 would be 4, x of 1, which is x of 0 plus 1, would be 1/2 of 4 plus 4 over 4, which would be 1 plus 1 is 2, half of 2 is 1, so on and so forth. And then if you calculate this to a higher degree, so if you did this to like 5 places, then it will give you a more accurate square root. I basically just want you to try and convert this into a program and see if it works. See if you get a program that actually works. And then if you scroll down in this Wikipedia article, it actually gives you the loop in Python. Don't look at that, but it does give you the loop. It's a little bit more complicated because it's starting with, it's doing it in binary, but this is basically the same idea. And if you Google it, you can definitely find some examples on how to do this yourself. So I encourage you to try this for yourself, see if you can get it working. And if you can, that's great. And I'll see you guys in the next tutorial, which we'll start discussing something called functions. Okay. If you like this, please hit like and subscribe, and I'll see you guys next time. Thanks.